All right, so we're looking at 415 practice data day one, and lack of better term for this because kind of mixing together a lot of the standards here. All right, so first here we got teacher drew a line segment that's 20 inches long on the blackboard. She asked each of the students to estimate the length of the segment and use their estimates to draw the dot plot. So how many students were in the class? So what you do is you count each one of these little dots, right? And so each one of the dots represents the student who answered, right? So the way you're going to do this is you just count how many dots there are literally. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 18. Right? So I would double check my counting. 1 and 3 is 4, 5, 10, 15, 18. Okay. Now, were they generally close in being accurate in their estimates of the length of the line? Explain your reasoning. Okay, so it was actually 20. And you could explain this several different ways. I'm looking at it like this. All of them except for 5 were within 1 inch. So you could argue no, yes, whatever. Me personally, I would say yes. All but 5 were within 1 inch. Okay, meaning they did a pretty good job in estimating. Okay, please put this in your words, not just in mine. You could also say the majority of them were very close. All right, number 2, Janice recorded the number of attempts it took each of her 12 of her classmates to successfully throw a ball into a basket. Make a dot plot of her data. So we're going to put attempts. Okay, so we got what we need to do. I'm going to move my little line up here. Is we're going to put underneath it any of the possible answers. So 1, 2, 3, 4, 5. So then when we record each one, we will need to mark it out. Okay, so you put a dot or an X. So like this. That one. That one. You could just go straight down the line too. I'm just looking for, so I got 4 1s right there. And then I got, here's a 2. And there's a 2. And there's a 2. 3 2s. And a 3. And another 3. Then a 4. And another 4. And then a 5. So that's a dot plot of her data. Right? Now we could do some things with that, but that's all it asks on this one, is to make the dot plot. All right, number 3, a movie theater is showing 3 different movies. The dot plots represent the ages of the people who were at the Saturday afternoon showing of each of the movies. One of them was an animated movie rated G for general audiences, meaning for kids. Do you think it was movie A, B, or C? Clearly, that would be movie B. Here's why. These are the ages, right? So all these are ages 4, 5, 3, 4, 5, 6, 7, 8, 9, 10, right? So the answer is B. Most people there were kids, or maybe and their parents, right? Because you see some who are over here in the parent age, right? So you can notice that the other ones, people are 20, 25, 30, 35, 40, right? All this, but not in the BB. Which movie has a dot plot with ages that center around 30 years? Okay, so notice clearly not B. A would be past 30, right? The center or the average of movie C would be about 30. What is a typical age for people who were at movie A? So that means like about the average age there. So something like, I don't know, you could put so around 40, right? Because it's a little above or a little below 40, or you could put something like, 37 to 46 or something like that. That would work too. Okay. Number 4, a group of students was asked how many children are in your family. The responses are displayed in this data plot. How many children responded to the question? So we got 1, 2, 3, 4, 5. That's 5. 1, 2, 3, 4, 5, 6, 7. 7, 5, and 7 is 12. 3, 4, 5. So I'm just counting each one of them. So 5 plus 7 is 12. Okay. Then 5 plus 2 is 7 plus 1 is 8. 12 plus 8 is 20. Okay. Again, you're just counting up each of the responses. What percentage of the students have more than one child in their family? Okay, so write the ratio first. Then remember, a ratio is a percent. Percent's a ratio out of 100. So more than one child in their family would be all of these. So that leaves these 5 out. Count all these up, you will get 15 out of 20, 20 being all the people that answered. We're looking for a percent, which means out of 100. Okay, so to get from 20 to 100 is times 5. 15 times 5 is 75. So therefore, 75%. Use some percents in the next few days here. And then what percent of the students have exactly 3 children in their family? It says 1, 2, 3, 4, 5. 5 out of the 20. So again, it's going to be times 5. So that's going to be 25 out of 100, which is 25%. And then it says, write a sentence that describes the distribution of the data shown on the data plot. Again, your answer should not be worded exactly the same as mine. All right. Let's see. I'm looking at most of the kids have between 1 and 3 children in their family, right? Because there's a couple that are over here at 4 and 5, but most kids have 1 to 3, right? Or you could put 1 to dash 3, 1 to 3, 1, 2, or 3 kids in their family. All right. So that is it for this practice. Remember that we are having a weekly review in addition to the daily practice this week. So make sure you have the plan for when you're going to get that done. That one's going in the major grade book. Okay. It's a review from some stuff we've not done a whole lot recently, and we really got to make sure we do before SC Ready test. Okay. Make sure you turn this one in.